Good morning. Welcome to Advanced Modular Development. I'm Mark Reinhold. My colleague Bateman and I will share speaking responsibilities for this session. A few quick poll questions to start with. Who was in Introduction to Modular Development yesterday? Oh, okay, good. So you've got the fundamentals. If you weren't there, who saw the keynote segment yesterday? Okay, so you've at least got an idea of what's happening. Great. How many people have downloaded and played with JDK 9 early access builds? Okay, that's a little more than usual. How many people have been really brave and downloaded the Jigsaw specific early access builds? 1, 2, 3. Okay, well, you are brave souls indeed. Okay, so let's get going here. This is the second of 3 sessions that we're doing here at Devoxx Belgium this week. We did introduction yesterday. This is advanced, and then this afternoon I'll be presenting Project Jigsaw Under the Hood, which is kind of a deep dive into the science of the module system, exactly how readability and accessibility work to give us reliable configuration and strong encapsulation. So this talk has 2 parts. The first part is about migrating applications, and the second part is about migrating libraries. So it's kind of a dual top-down versus bottom-up kind of a thing. I'll do the first part, and Alan will do the second. So, application migration to begin. At heart, a typical Java application has 3 layers. At the top, you've got your jar files. At the bottom is the JDK. And in the middle of this kind of sandwich thingy is the filling. It's a bunch of jars that you downloaded from the internet and threw in the class path and tested, and they hopefully seem to work. In Project Jigsaw, we've turned the JDK into modules. So the bottom layer here is now these pretty modules. In this case, we have Java Base and Java Logging and Java SQL and Java XML. The benefits of modules are twofold. You get strong encapsulation so that no one outside of a module can access its internals, and you get reliable configuration. So modules know what they need, and there's no need for you to configure the class path and deal with all of its inherent brittleness. If this sounds good, you might be wondering how to turn your application into modules. Let's put some names on these jars, the light blue ones, to get started. Let's assume that the main application is myapp.jar and it has some helper code in mylib.jar. Let's assume further that this cloud of third-party jars is actually just 3. It can be simplified to just Jackson, the JSON processing library. Jackson comes as 3 jars, the core jar, data binding, and annotations. Of course, to run the application today, you have to ensure that the class path is set up like this. You wouldn't have to bother with that if myapp.jar and mylib.jar were actually modules, as shown here. Turning each jar that you've already got into a module is a fairly natural way to proceed. It's not always possible, especially if the jars have cyclic dependencies amongst their classes, but let's assume that that's okay for now. Now, whenever you see a module, you should ask 2 questions. What does it require, and what does it export? Requires is how we get reliable configuration, and the exports are what determine strong encapsulation. Let's ask these questions for each of our prospective modules here, myapp and mylib. One way to find out what a module might require, especially if all you've got is the jar file, is to run jdeps on its jar file. jdeps is a tool in JDK 8, and it's actually been updated quite a bit in JDK 9. It analyzes classes in jar files and finds whatever classes they refer to in other jar files or in the JDK itself. These are the results of running jdeps on myapp.jar and mylib.jar. The classes of myapp.jar make use of classes in jacksoncore.jar and jacksondatabind.jar, and of course also mylib.jar. Plus, myapp.jar uses classes from the base module like object and string, and from java.sql. Mylib.jar is just the last line here. It only uses classes from the base module, so that's nice and simple. With this knowledge, we can write the module declarations that we need for our two modules. Here's the moduleinfo.java file for mylib. All it requires is java.base. We don't actually need to write that, of course, because the compiler will insert it for us, but it's shown here just for clarity. Now, JDEPs can't realistically help you with exports. So let's say that mylib exports a package called com.myapp.lib.util to the myapp module that we're going to make in a moment. This is a qualified export because it's specific about which other modules can access the package. Now, let's turn to the moduleinfo.java file for my app. It requires mylib, the module that we just created, and Java Base and Java SQL. And of course, we know it's going to use Jackson, so we'd like to write requires Jackson core and requires Jackson data bind. But wait a minute, does that mean we have to write module info files for them too? That would sort of be a pain. If only there was some way for the Jackson jar files to somehow become modules automatically. Well, indeed, there is such a way, and that's called automatic modules. If we had those, we can write the moduleinfo.java file for my app like this. We have a beautiful module graph with my app depending on mylib and Jackson core and Jackson data bind, and also on Java Base and Java SQL. So automatic modules, an automatic module, it's a jar file that you just put on the module path rather than the class path. Once you do that, you have a real module. You don't have to change the jar file at all. The module name is derived from the jar file name. It exports all of its packages, and it requires all other modules. In effect, automatic modules mean that today's jars are tomorrow's modules without change. Once automatic modules spring into existence for Jackson core and data bind and annotations, the module graph looks quite different. The automatic modules basically require everything. They require each other and all the modules in the JDK image and all of your modules as well. The reason for this is to provide the maximum compatibility surface for code in jar files. You might think that the module system could run JDEPs on the automatic modules at startup and try to figure out which modules they require, but not only would that be slow, but it, in the end, wouldn't actually help very much. And the reason for that is that libraries you find in the filling of the sandwich, if you remember, often make use of core reflection, the JavaLang Reflect API. And they do this to inspect classes dynamically. I mean, this is how frameworks like Jackson data bind work. JDEPs can see the use of core reflection, but because the names of classes reflected upon are typically computed dynamically, there's no way to determine upfront which classes will be inspected. So this just shows how Jackson data bind is doing the reflection thing. When code in my app calls the Jackson API, it passes its own class object. The intent is that the Jackson data bind module can create an instance of my value. But this won't succeed because we never got around to saying what my app exports, because it doesn't really have an API. We didn't write an export for it, but it needs to export some packages at runtime anyway. And this is a common thing that you run into when you use frameworks. It's quite likely you would find this in your own application code. The solution for this problem is to declare my app as an open module. You put the open modifier in front of the module keyword. An open module opens all of its packages in a way that allows a framework like Jackson data bind to reflect over its internals. In effect, you get the benefit of reliable dependencies, but without the full power of strong encapsulation. Frameworks that reflect over application code are a reality in everyday Java development, and they aren't going away. It's important to support them. So application code can't always be strongly encapsulated. We think that the open modifier is a clear statement about the nature of this module. It's open for reflection, but it's definitely not exported for compilation. Without the open modifier, a module is strong. It explicitly defines an API via exports clauses, and is not intended to be deeply reflected upon by frameworks, although you can actually arrange that on a per package basis if you really want to. So let's come back to the overall module graph. It is pretty messy, but it's way better than when everything was a jar on a class path. For example, in the module graph here, there's no arrow from mylib to myapp, so there's no danger of code in mylib accidentally reaching into myapp's internals. On the class path, code in mylib.jar could access code in myapp.jar quite easily, and that's what causes maintenance headaches further down the road. If you think about it, the class path is actually pretty insane. With just 10 jar files, you get 100 possible ways for code to interact, because the class path is a way for looking up arbitrary classes regardless of what jar file contains them. In a sense, the class path is the ultimate in erasure. Whatever you know about the structure of your system, the class path throws it away and connects everything to everything else. This means that conflicting classes and missing classes and generally slow lookup every time the VM needs a class, which is actually, well, pretty often, right? With modules, you're telling the compiler and the VM what you know about the structure of your system, and finally, they actually hear you. Speaking of the compiler, let's see how to run it. We've got the Jackson jar files in the lib directory. We treat them as automatic modules by putting them on the module path with the module path option. We've got the myapp and mylib source in the source directory. We tell Javac about this with the new module source path option. This is required because there's a new level in the directory hierarchy for the modules themselves. It goes source/module name/moduleinfo.java and then the regular old package hierarchy. The result is class files in the mods directory. We run jar to build mylib.jar based on the classes in mods/mylib. Then we run jar to build myapp.jar from the classes in mods/myapp. We also specify the main class with the main class option. Because the jar files have modulareinfo.class files, we refer to these as modular jars. You can run your modularized application with this very simple command line. You give the module path, and you tell it the name of the module to start with. All of the information in the class path from the past is now wrapped up in the modulareinfo.class files. Remember, the explicit modules are located in mlib, and the automatic Jackson modules are located in the lib directory. That's why there are two things on that path. So to recap, we modularized this little application with two techniques. First, we built modular jar files for our own code by writing and compiling modulareinfo.java files. Second, we created automatic modules for third-party code simply by putting their jar files on the class path without touching them. If you like, you can think of this as top-down migration, which probably makes you wonder, is there also bottom-up migration? Well, indeed, there is. To answer that question, here is Alan.
Okay. All right, thank you. Library migration. So for this part of the presentation, you can just forget most of what Mark said for the last 10 minutes, because we're going to start at the bottom and work our way up. So we're rolling back to the slide that Mark had near the beginning, where we have the platform modules at the bottom, and then we have this big cloud of jar files that we are going to now attempt to migrate to explicit modules. We use exactly the same example. We will use Jackson jar files, 3 jar files, and we will make the assumption that they're well formed, there's no split packages, there's no cycles. In other words, they're actually good candidates to be modules. So our goal is to migrate what is in light blue in this cloud of jar files. We're going to migrate them to nice green modules. So in these slides, green is module, orange is a class path. So what we want to get to the point is that these modules declare exactly what they do. They declare their dependencies, and they also declare their exports so that they can take advantage of the reliable configuration and the strong encapsulation that Mark talked about. So exactly as before, when you meet modules, you have to ask 2 questions. What do they require? What do they export? We've got 3 potential modules here: Jackson Core, Jackson Data Bind, and Jackson Annotations. So we're asking the same question of each one of these 3 modules. Mark showed JDEPs doing a static analysis on myapp and mylib we can do the same thing with the Jackson jar files by running JDEPs and get an idea what their dependencies are. So Mark mentioned that JDEPs is a very useful tool. It's in JDK 8 for doing static analysis and getting an idea of what the dependencies are on jar files. In JDK 9, it has a whole bunch of new options, and we'll be showing some of those as we work through it. The JDEPs-S gives us a summary of the dependencies. I give it as input a class path of jar files or a set of jar files, and it prints out what the dependencies are. In this case, Jackson annotations and Jackson core are very simple. When you do a static analysis on them, there is the only types that they reference are in the base module or Java base where Javalang string and Javalang object exist. The Jackson data bind module is more interesting in that it has static references to types in other platform modules. It also has static references to types that are in the Jackson annotations and Jackson core modules. So from the output of JDEPs, we can actually construct a little diagram that is the dependency graph. At the top, we have Jackson data bind that depends on Jackson core. It depends on Java SQL and Java XML, and of course Java base, because every module depends on Java base. Core and annotations are much simpler. They only have types that reference types in Java base. So just keep this dependency graph in your head, because we'll need this as we work through it. I'm not going to use JDEPs again. This is an option that allows me to generate a candidate, or at least an initial starting point for my module declaration. So the --gen-module-info is an option on JDEPs to generate a starting point for your module declaration. It generates a module info.java for each one of the jar files that you give it. There's two options. There's an option to gen module info, which is a directory where it will generate these initial starting source files. So when I run JDEPs on the 3 jar files, it will generate 3 module info.javas in src / the module name, and then the name of the file is module info.java. So this JDEPs option is not in JDK 8 because JDK 8 does not know anything about modules. This is a new option in the upgraded version of JDEPs. It's in JDK 9. So let's look at one of these module infos to see what JDEPs has generated. And we're going to look at the generated module info for the data bind module. The reason we're looking at that one is because it's the most interesting one. So at the top of the module declaration, if you remember from yesterday, all modules start with the module keyword, the name of the module, open curly brackets, and then the requires and the exports clauses. For the requires, JDEPs has generated a requires clause for each one of the dependencies that it sees with the static analysis. It additionally does an analysis on the signatures of the methods for each type in these jar files. So it knows whether there's references to types in other jar files or other modules in the signatures, and that's how it's able to be able to include the transitive modifier or not. If you remember from the intro slide, you use the transitive modifier when you have a module that has in its API signature some types that are in other modules. You don't want the consumers of your module to have to go and remember to do a requires on this other module that you're exposing types from in your API. So JDEPs is able to do that, which is a good starting point for generating the module declaration. JDEPs has no idea which packages in the jar file are part of the API that are in that library. So it generates an exports clause for every single one of the packages that are in that jar file. Now for this part of the presentation, we will pretend that we're the maintainers of Jackson library, or the Jackson JSON APIs. And we will know much more about these APIs. We will know which API packages are really part of the API. We'll know which are the implementation packages. So we'll be able to edit this and remove the lines that don't make sense. And that's exactly what we will do in the next slide. We will assume I'm not one of the maintainers of Jackson, but we will assume that we are, and we will assume that anything that has a .impl in the package name is internal implementation and should not be part of the API. So if I were to edit this generated module info.java, the first thing I would do is actually remove these lines because they should be not exported. I don't want any of the consumers of this module to be making use of the types that are in the impl package. There may be a lot more, maintainers should be able to have a lot better idea as to what their API is. I would hope that the Java doc that they produce for this library will only include the packages that are part of this API. But the point is, this is a good starting point to get to your module declarations for these libraries that we are migrating to explicit modules. So now let's go and compile our 3 module declarations, and we will compile it with the rest of the source for these 3 Jackson libraries. We will assume the same module source code layout, which is src/module name, and then the module info at the top level directory of the module source, and then all the packages organized as they traditionally are. So this is a module layout where you've got an additional module name as in the full path to the source. I'm using the javac --module-source path, which is the multi-module compilation. I'm going to compile all 3 modules with one javac command. So I'm just using a bit of shell foo with using find to find all of the Java files that are in the source tree, and I'm going to compile feed those to javac, and it will compile them all into, in this case, the mods directory. So the -d to javac specifies the output directory. They're all going to be compiled into the mods directory, and javac will do the right thing and compile them into mods/module name, and all the class files will be created under that. We've now got our modules compiled. I'm now going to package them, and I'm using the jar command and some of the new options that there are to the jar command in JDK 9. So in the intro presentation yesterday, we talked about some of the new options to jar, because jar has been significantly modified to support GNU-style options, to support options to support modules, and we're using some of the new options here. So I'm using jar --create --file, and I give it the name of the jar file. That will create this jar file. I'm giving it the location where the class files that are going to be packaged up into the jar file. Additionally, I'm using the opportunity to add versioning information to the packaged module as part of creating that packaged module. So this is the opportunity to add versioning information, which is useful for diagnostic and reflection purposes later on. So 3 jar commands to create 3 package modules. Now let's look at the resulting module graph. Remember, green is module, orange is our class path, because we've left myapp and mylib on the class path for this part of the presentation. This is a much cleaner module graph now. Each of the modules has a small set of dependencies and very, very clear what they depend on. So it's a nice clean graph. No cycles. Now I'm going to run this. Now running this is a little bit complicated initially because I am mixing the module path and the class path. Myapp and mylib are still on the class path for the command I'm going to show you. And this is the original command, I should say, where we had everything on the class path. We no longer have the Jackson libraries on the class path, so this is the command that we end up with. So this command will initially look complicated because I'm mixing modules and the class path. My class path has myapp and mylib exactly as before. For the module path, I give it the --module path option to give the Java launcher the location of the modules. And I additionally have to give it the add modules option to tell it which modules to resolve. Remember what I was saying yesterday at the intro slide, our intro presentation. My module path may have thousands of modules in there. There is nothing in the application on the class path to say which modules it needs. So I have to give a hint to the Java launcher to tell it which modules to resolve. I know that my app and mylib my app makes use of the data bind module, so I'm having to tell the launcher, please resolve the Jackson data bind module and locate that on the module path. So this is what the command looks like, where I've got modules from the bottom up, and I've still got my main application and some helper library on the class path. So now we can start putting things together. And when I say putting things together is, we've in this part of the presentation, we've started at the bottom. We've migrated some of our libraries to modules. At the beginning of the presentation, Mark migrated my app and mylib to modules. When we combine them together, we end up with this nice module graph where it's modules all the way from the bottom up or from the top down. Right? When I look at my app and mylib, it's clear what they depend on. When I look at any of the jar files in the middle, it's very, very clear what they depend on. Now I'm going to start running these all as modules to see how this looks. So mylib directory, if we look in there, we've got 5 modules. So these are the modules that Mark created at the beginning of the presentation, and the 3 Jackson modules that we have created in this part of the presentation. The command that I'm using to run this has now shrunk a little bit, in that I'm just giving it 2 options. The module path where it finds the modules, and the -m option to give the initial or the main module, and that will just run. So that's really, really nice. But we can go further. We introduced the linker yesterday, and I'm going to use the linker now to actually generate a runtime image that has my app in there, and we will see how that works. So this is the JLink command. Yesterday we used the JLink command, a very, very simple version of it, where we just asked the JLink tool to create me a runtime image that had a small set of modules in it. We will do the same here, but we will use some more advanced options. Exactly as we do with Java C and the Java launcher, we give it the module path where to locate the modules. We give it the add modules option to tell the linker what modules that you want included in the runtime image. The JLink tool will generate the transitive closure and will create a runtime image in the output directory that I give in the --output directory. Because this is the advanced presentation, we'll use a couple of advanced options. I'm using the --compress option to do some compression on the image, and I'm also using the --strip debug because I want to strip debug information from the class files and make the resulting image a little bit smaller, because I may want to redistribute it, for example. So running JLink, what I end up with on this example is a runtime image that is 26,000 bytes, so just over 25 megabytes, which is not too bad. When I look in the bin directory of the resulting image, I see the Java launcher as before, and I also see that the linker has generated a launcher for my app. When I run the list modules option with the Java launcher in this runtime image, then I see the modules that have been linked in. So this is the transitive closure of my app. My app depends on mylib. My app depends on Jackson data bind, and Jackson data bind depends on Jackson core and Jackson annotations. And there's a small set of platform modules that have also been linked into this image. So I've ended up with 4, 7, 9 modules in this runtime image, which is really nice. So now let's shrink the command down a bit more. For this runtime image, I can just do java-m my app. I do not have to specify the module path to this command, because all the modules are in the runtime image. It doesn't need to go and searching on the file system to go and find my modules. And because we have generated a launcher, which is what the JLink tool does when it sees modules that have an entry point, it will generate me a my app launcher, and I just need to run that, and no command line options needed, which is really nice. So I've shrunk my command line again, and because there's no additional dependencies, no options, no module path here. And that is it for this deck. The main point is that the module system allows us to adopt modules at our own pace. What Mark did in the beginning of the presentation is he migrated some application and a helper library to modules without requiring the libraries that he depended on to also be migrated. You can actually start migrating applications before the libraries. Libraries additionally can be migrated to modules before before other libraries. They can be migrated independently, and that's really, really powerful, particularly when we're actually retrofitting the platform to support modules when there is so much of an ecosystem and so many libraries out there. So it's really, really good that you can actually migrate libraries independently of others. You've also got a flavor of the types of modules that are in this proposed design. You've got the explicit modules, where I've created a module declaration. I've typed module space module name. I've declared what the dependencies are, what packages are exported. And you've also seen how the automatic modules, where there's no module declaration. I'm just using today's jars as modules on the module path without any module declaration. They're automatic modules, so it gives you a flavor for that. We didn't go into a huge amount today on the normal modules versus open modules. I say normal modules in quotes I really mean modules that just have module space, the module name, versus the open modules, which are essentially open for deep reflection by frameworks. Mark touched on it, and maybe another day we might do a presentation once this is more baked on what this actually means. But I hope you've actually got a flavor for migration and the different types of modules in the module system. So we'll end up with one final sentence on the slides here. Go forth and modulize. So more information. We're developing the module system in Project Jigsaw. So this is the link to the project page and the mailing list, and also the early access builds. The early access builds of Project Jigsaw are a little bit ahead of the regular JDK 9 builds because they are a bit more bleeding edge. They have implementations or early implementations of some of the features that aren't quite yet ready or quite yet agreed to bring into JDK 9, but we hope to address that soon. And that's it. So we have a lot of time for questions. So I think Mark is going to come back up for questions on this. So now in terms of logistics, there's a microphone that's up here under the lights, and it would be easier if you have questions just to use the microphone, because it's very, very hard to hear people here, and also because this session is being recorded, we would otherwise have to repeat the question and probably get it wrong.
Don't all get up at once.
Yep. Someone running.
No, they're just leaving.
Do you have any timings on your startup time, and what do you save by actually packaging all this stuff into a nice compact package?
Sorry, what was the beginning of that? The mic wasn't on.
Do you have any timings on how much you save on startup time and all that good stuff?
Startup time. So through the heroic efforts of Alan and others, we've managed to reduce startup time by just a little bit, which probably doesn't sound very impressive. But if you think about it, it actually is, because now when you start up even something trivial like Hello World, the module system is kicking into gear and going and finding modules and reading module.class files and doing resolution and doing all the consistency checks and setting up all the module information in the VM. So it's doing more work, and it's taking a little bit less time. Now, so that's just the immediate effect. We do expect longer term that modularizing the platform will enable a bunch of other kinds of improvements to startup time. The most promising one is probably ahead of time compilation to native code. Is it in yet or not quite, the AOT stuff?
In process.
Yeah. So on its way into JDK 9 as a somewhat late breaking feature is an AOT compiler. It's in 9 it will only be on Linux x64. It will be used to ahead of time compile the base module, which is where all of this startup stuff happens, and that should give us another boost in startup time. In JDK 9 it will actually be available for experimental use on your own modules. So if you want to go play with the AOT compiler and all of the advanced stuff that it can do, then feel free and let us know what you learn. So high level startup time has two aspects. One is we've managed to not only preserve it but reduce it a little bit in the near term. The other is the long-term enablement of related technologies such as ahead of time compilation.
I was thinking specific of your My App application, where you've gotten rid of a lot of megabytes, where you actually end up with a pretty small package.
So the fact that the image is smaller probably helps some in terms of just, I don't know, cache behavior and paging and whatnot, but I don't think it's going to have a huge effect
I think
on the startup time per se.
The main thing with having a small runtime image is it's much easier and much smaller to redistribute. So instead of distributing the entire runtime in every one of the JDK modules with your application, if you're redistributing this small image, then it's a lot better.
Yeah, and it's not just redistributing, but if you're, for example, deploying in the cloud, you can make a small Docker image that is then cheaper to replicate, across a bunch of machines and a bunch of instances. Rather than a half gigabyte Docker image, you can have maybe a 100 megabyte Docker image, and that's generally a good thing in a cloud environment, right?
Thanks.
A small question. I saw the command line parameters changed in the latest JDK 9 builds, but what was the reasoning to change the shorthand version of module path from -mp to just -p, which doesn't sound logical to me.
JEP 293 has the guidelines. Is it 93? Someone do a quick Google on JEP 293. I think I've got the number right, but so this is an informational JEP. Sorry, JEP is JDK enhancement proposal, so this JEP outlines has all the guidelines for moving to GNU style options, which is what we're trying to do in JDK 9. So we're preserving all of the original options that have been in the JDK, but we're moving to the GNU style. Where it makes sense, these long verbose GNU style options have short forms, and the guidelines is that they be single character options, and that's why we moved from in the early builds we were using -mp, but we've actually moved to -p, which is, just think of it as path, and it actually works quite well once you get over that transition.
Okay, clear.
But
Thank you.
all of the old options work as before.
Hi, I have two questions. First question is, you have to give it in the mylib module info exports of each and every classes that you want to export. So let's say that today, if I'm releasing mylib with some set of APIs that I want to expose to another app, and then tomorrow or after the next release, I want to have some more APIs to be exposed, then I'm forced to recompile with the module info containing the list of exports, new APIs. Does it not, because earlier it is easier that all public APIs are exposed. Now it is not the case from JDK 9. So don't you think that it has more delivery cycle more, than the earlier versions?
Do you mean, is it more effort?
Yeah, I mean, it has to come through the development, R&D, and then delivery. It has to go because you have to change in the module info.java to contain the new APIs that you want to expose.
Well, presumably you're recompiling your application because you're adding new APIs.
Not necessarily. Initially, I have all the APIs already available, but then I didn't expose it initially.
Well, I assume you didn't export all the packages initially because you hadn't decided or they weren't quite ready for release, and then it's just another update of your library. I really don't see.
So the intent is that modular-info.java lives in your source code along with all the rest of your source code, and that whole body of source code defines your module, both the sort of module part of it and the module info, plus all of the regular Java source files that define classes and interfaces or whatnot. So that thing as a whole needs to make sense. You can have one version of it that exports one package. You compile that, make a modular jar, ship it, and then 3 weeks later decide, oh well, now I need to export an additional package. So you've got your source code in Git or whatever. You add the export to the module info.java, you make whatever other changes you need to your code, compile it, package it, and ship it. It's meant to be one thing. So it shouldn't be a ton more work, and the advantages you get in terms of strong encapsulation, we think are generally worth the effort.
Okay. And the next question is, earlier versions of Java had the option of dynamic class loading and everything. Now, does it mean that in the module info, only those that are exported can be accessed? So that boot class path, finding the public APIs that another class can dynamically load are all affected? I mean, it will not be allowed.
Dynamic class loading has not gone away.
Yeah.
But there are now further constraints. If a module does not export a package that contains a particular class, then from outside that module, actually the class can be loaded, but you won't be able to access anything inside instances of it.
So all earlier all public methods and APIs can be accessible, but now it is not the case.
Yes, that's true, and I'll cover this in a bit more detail in the Under the Hood talk this afternoon. There is this somewhat counterintuitive thing going on here, where forever, for 20 years, public has meant public. If you can find a class, you can access, everything that's public in any particular instance. Now, public no longer necessarily means public. Public will mean you can access it if it's exported and required going in the other direction.
Yeah. And the short-term implication of this, at least for existing applications, is they just won't be able to access JDK internal APIs. So there may be some sun.star API that is public, it is no longer accessible in JDK 9.
Yeah, thanks.
Mm-hmm.
I'm trying to get my head around this whole Jigsaw. So I'm wondering, is Jigsaw just a run and compile help tool, or is it also used for dependency management? Because what I have not seen yet, maybe it was in the introduction part, I would actually expect on the requires part of the module info.
I know exactly what you're going to say. Keep going. I know exactly what you're going to say. Sorry, keep going.
Well, that's my question. I see that you declare a version of a module in the package info, but not in the requires. So,
versions in a package info?
oh, that's what I just understood from your colleague.
No, that was at packaging time. I was giving the version string to the jar tool to add it to the packaged module.
Right. Okay. So some of you have probably heard this answer before. I'll give it again.
Yeah.
First time today.
I wasn't at the introduction yesterday.
That's okay.
Sorry
No worries. This is probably the most frequently asked question. Okay. Why aren't there version constraints on requires? Why can't you say requires Jackson.data bind version greater than 1.3 and less than 2.9 or something like that? Well, there's a little story behind that. Early prototypes of Jigsaw, some years ago, we actually did have version constraints on requires. And we were thinking about, well, how will this module system interact with all the build systems that people currently know and either love or hate or both, right? And we realized, well, Maven's got its way of dealing with version selection and dependency management and handling conflicts and everything. And then Gradle has a somewhat different way of doing that is even more flexible and configurable. And there are a few build tools and kind of in the long tail of build tools that do things in yet other ways. There might be future build tools that do things in maybe more optimal ways. We were actually on the verge of integrating a very sophisticated solution to version selection in this early prototype. At the same time, fortunately, we were thinking about this build system interaction problem, and we realized, wait a minute, if the module system did version selection and dependency management, whatever we do is going to be different than some popular build tool out there. And it's a complete non-starter to say, okay, everybody, you want to use modules, you need to throw away your build tool. You can't use Maven anymore. You can't use Gradle anymore. That would just be like, huh? You guys are insane. You're not yet. That completely unrealistic expectation. So it's really important to work with the existing tools ecosystem. And then thinking about it further, we realized, at an abstract level, modules are kind of, they're a little bit more on the, some sort of platonic ideal of a program component. It actually, there's a perspective where it makes a lot of sense for modules to be independent of things like versions. So modules are this fundamental new kind of program component. They're like classes with a wider scope and somewhat different characteristics. And it's perfectly fine to have a build tool. It's actually a good thing. The build tool is what intermediates between the somewhat abstract notion of modules and the very concrete and real-world messiness that we find in build systems and Maven Central and the real world of jar files sitting in file systems. So that's the perspective that we've taken. And it is a little bit surprising, it is a little bit dissonant to many people at first, but most people, our experience has been, once we explain this and they think about it, I was like, oh, well, okay, yeah, maybe that's not so bad. And you work with it for a while and it actually will become fairly natural, at least in our experience and the experience we've heard from others so far. So that's why there are no versions in the module system.
Okay, I hope it works out.
We do too.
I even see on OHDI that the services that you use, you have different versions, and so that's only runtime. So yeah, okay, we'll see how it works out. Thanks.
We will. Yeah, I mean, a related point I'll make, just we've got some time, is another related question that people often ask is, well, why don't you support multiple versions of the same module at the same time? And that was another big simplification we made some years ago. It makes the entire system much simpler. If you can do multiple versions of the same module at the same time, but you have to go use a somewhat more advanced API, the layer API, which is there for container applications and sophisticated applications that actually need to support that kind of thing. But if most applications that don't run in containers, like app servers or whatever, most applications, they live on the class path today. And today on the class path, if you have multiple versions of a jar file, you're in trouble. You might not know it yet, but you're in trouble. So it's actually not that necessary for normal applications to support multiple versions. So we don't.
Okay, thanks.
This is kind of a big question, so feel free to answer it the way you want. With regards to class loading, it seems like the number of classes that are now available on the class path are fewer because you can limit that.
In fact, maybe zero.
Right. On the other hand, it seems like the algorithm for looking up those classes is a little more complex because for example, automatic modules, you can make that graph really complicated if you don't know what you're doing. So my question is basically with regards to performance and also with regards to maybe unexpected side effects or gotchas or whatever that future developers might encounter with regards to modules. Any tips, any info, that kind of thing.
Okay, well, in terms of computing the transitive closure and the resolution that happens at startup, it's actually pretty fast. It's under 5 milliseconds at the moment with JDK 9. Now, if you come along with a big module path and you've thousands of modules in there, it actually scales pretty well. We've actually written quite a few benchmarks to exercise module paths with thousands of modules, tens of thousands of modules, compared it with the class loading performance of the class path, and it just completely beats the class path, of course, because once modules have been found, there is no longer any linear search of the class path to find types. So it actually works out quite well.
Yeah, and that's a huge win. I mean, 1,000 jar files on the class path, when the VM goes to load a class, it starts at the beginning each time and looks in each one, right? Once you've resolved the module graph and set up the class loaders with the proper delegation, then the module system knows that for any given package in any given module, you go here right away. You don't need to look in any other artifact, just that one.
Thanks.
I had a question about the linker. Previously, if I want to, if someone downloads my application, you download a jar, and it uses the installed Java, which then is updated with security.
You can still do that.
Still
The
works.
linker
Yeah,
does
sure.
not replace that. It's a new thing you can choose to do.
But therefore, I've got the question, in the exported image, you have part of the JRE. Are there plans to leverage, let's say, the optional presence of an installed JRE that is updated?
No. No, I think you choose one way
Yep.
or the other. And there are many applications where making a custom image is actually not the right thing. You continue to ship a jar file or an executable, uber jar, fat jar, if that's better for your scenario.
Okay, thanks.
Linking is not meant to replace every current use of jar files.
Hi. My question is related with the fact how you would use how to migrate actually our applications currently. I suppose the modules are loaded more like as they are required, as with the classes are loaded only when they are actually needed. Is there a way or a flag or something to add actually all the modules? And this would also facilitate us to actually go and upgrade to JDK 9 earlier.
I'm sorry.
I'm sorry, I didn't understand what you. So you're asking, is there a flag to do what?
To add all the modules in, to have it available, and to not have to search for each individual dependencies that I have, and actually just put everything there. Like I have it actually right now in JDK. I have everything from JDK available.
Right, so when you run an existing application on the class path with JDK 9, then it works as it did with JDK 8. All of the platform modules that are linked into the runtime image, they're all available to you. They're all so all of the types in those modules and all the APIs that you're using, they will all just work.
Yes, but
Yeah,
as I
but
understand, only the Java base is implicitly
No.
added.
No. So when you run okay, so there's actually a JEP 261 where all this is really documented, but when you run something on the class path, all of the modules that export APIs that are in the system image are you could just think of those as being resolved at startup. So if you're using, I don't know, let's say you're using Swing or AWT and they're in the desktop module, then the desktop module will actually be resolved at startup when you're running a class path application. Now,
Without the necessity to require the Java desktop?
Well, you're on the class
No.
path, so you've got no requires. Now, if you were to migrate your application to a module and you're writing a module declaration, then you will put requires java.desktop, and that will cause that module to be resolved. But if you're just moving from 8 to 9, it'll just work exactly as it did before.
Yeah, in general, we've taken great pains to make sure that if you have an application that works on the class path today with 8 or an earlier release, it only uses standard supported APIs, then the same command line will work with 9. As I showed yesterday in the keynote, a copy of SwingSet 2.jar from 2004 runs perfectly well on 9. You just type java-jar SwingSet 2.jar and it works. So you don't need to think about base or anything else. You can completely ignore the existence of the module system if you want to.
So this will happen only when you start to actually implement a module.
Exactly.
You only need to think about it if you start to use modules. When you just run SwingSet internally, the launcher is doing resolution, but only on the built-in platform modules. You're completely unaware of it, and that's as it should be.
Thank you.
Mm-hmm.
Hello. When and how would the modules be available in GEE?
In what?
Java
Java
EE,
Enterprise Edition?
Oh, Java EE, right. Yeah, so little tip, do not ever say JEE in front of any of the Java EE spec leads. They will flip a lid. That's an excellent question. As you might expect, we've had quite a few conversations with EE spec leads and other people in the Java EE world. It's not up to us, obviously, but clearly, the intent here is that a future version of EE will will adopt modules in a sensible fashion, and there are features in the module system specifically meant to support application servers and those kinds of scenarios. My guess is that EE9, since the number matches, will be the one that has modules integrated.
But if GE8 runs on JDK 9, would modules be supported by?
If you write an application using Java EE7 or Java EE8, it will run perfectly well on Java SE9. It'll be completely unaware of the fact that there are modules under the covers.
Okay, thank you.
Mm-hmm.
It follows the previous question. You have now an option in Maven to give when you are making app var files, as the container will provide these libraries. Now when we are moving to Java 9, how are you, module info is going to dictate one version, but you cannot be sure that in the app servers that particular version is going to be available.
No, until the Java EE specs say how modules work in a Java EE environment, there is no concept of modules in Java EE. So Java EE7, Java EE8, they should run fine on top of Java SE9, but modules are something of which they're completely ignorant, and that's fine. Make sense?
Yep.
Okay.
Any news about optional dependencies? Are they in or out scope?
Requires static.
Try out the Jigsaw early access build.
Yeah,
Okay,
that requires static has been in for a few months. Requires static is a way to say that a module is it has to be there at compile time, but you're willing to write code to deal with its potential absence at runtime. It's also useful for things like modules that only contain annotations that you don't want to bother to worry about at runtime.
Okay, thank you.
Mm-hmm.
Hello, thanks for being here.
Thank you.
Do we have time for one more?
Yep, at least.
Okay. I was wondering, why do we need to specify transitive dependencies? Why doesn't it just figure them out?
What do you mean by what do you mean by transitive dependency in this case?
Okay, if I'm not mistaken, in a talk yesterday, you said, one of you said, that in the file that specifies a module, you need to also specify the transitive dependencies, the dependencies that module that you depend on.
You mean with requires transitive?
Yes, I believe.
Okay, right. So this is a potential confusion of which we're aware. So requires transitive is not actually specifying the transitive dependencies as you might think of it from Maven. This is what we used to call this requires public, and that was an even worse name. Requires transitive is less than ideal, but we haven't found nor heard of a better suggestion for the term. Requires transitive is how you specify implied readability. So if you're writing a module that just needs some other module for its implementation purposes, you just say requires. The module system does all of the transitive closure computation. What requires transitive means is a very local kind of transitivity. If, say, your module uses java.sql types not only in its implementation but in its API, then it requires transitive is a way of conveying to users of the other modules that use your module, hey, for free, you also get a virtual sort of requires on java.sql. You don't even have to say it. So it's a very local transitivity that you're specifying for the benefit of modules that use your module. If anybody has a better term, we're open to suggestions, but this is one of those really hard naming problems. It was requires public for a long time, and that made sense in a certain way, but was confusing. Now we're at requires transitive, which has this other confusing thing to it. But we've been through long lists of words and looked at many thesauri for this, and nothing better is cropped up. So we only have
1 minute.
Less than a minute left. Oh,
Oh, time
time
is
is
up.
up, in fact. So
Right.
thank you very much.
Okay.